Alright folks, welcome to the fourth video in my Learning C++ series. I'm Sean Ramsey. Today what I thought I would do is use a different machine, running a slightly different OS, and running a slightly older version of Visual C++. The point here is to show you that C++ really isn't changing horribly fast. There are some new things coming out here and there, but not in the basic step that we're learning right now. It's been this way for a really long time. And that you can use other tools, other compilers, other things like this, and a lot of them will work the same way. Now, we're using Visual Studios again, so it's not going to change too much. You'll see that I select Visual C++ and Win32 console application. Today we're going to learn about variables, and we're going to learn about console input, so I'll just call my project variables. You can see this window hasn't changed in a long time. My theme is a little brighter here. I do prefer the dark themes. I don't know that there were themes back then. There probably were somewhere, although I don't know how to make them. And so here we go. I'm creating a new source file here. I'm going to name this variables.cpp because we're going to learn all about variables. Okay, the shell of all of our programs is going to be the same as always. It's #include iostream using namespace standard. Int main, have to catch up to my talking here, int main, and the shell here. You can see that it doesn't auto-complete some things as nicely as the 2015 community version of Visual Studios does. That's okay. Let's talk about variables. The first thing you need to know about variables is that they have a type, and each of those types has different limits. In specific, there are only really a handful of base types that you need to know to survive in C++. I'm going to talk about a few of those. I'm not going to talk about every single type possible. I'm just going to talk about the basics. And so the basic type that you're going to interact with to start, or at least in this tutorial, is going to be an integer. And in C++ they're called ints. If you want to make a variable, you need not only to have a type, but it also has to have a name. And the name is a special kind of thing in most programming languages, and in particular in C++. It's called an identifier. Now, names can really be almost anything that you can think of. There are some rules and restrictions. They contain numbers and letters and underscores, and they can only begin with letters and underscores. And so if you can think of any word, that will probably be a valid identifier. One thing to look out for is that you can't use another C++ keyword as an identifier. So you can't make an integer called the name int. Okay. There are a lot of C++ keywords: if, break, continue, for, int, float, double, char, or char. There are a lot of those. And you simply can't declare a variable called that. If you do happen to pick one that's already a C++ keyword, you can see here it gives you a little red squiggly line, and it says error expected an identifier. Okay, great. So let's not do that. So we're going to make some sort of identifier. So if we were going to make a variable for the speed of our car, we might call that variable something like velocity. Now this begins with letters and contains letters, so this is a valid identifier, so this is perfectly fine. If you were going to create a variable that tells you how fast your car is accelerating, which is slightly different than its velocity, then you might call that variable acceleration. Something like that. Okay? These are integer variables, and what that means is that they can only contain integers. Numbers like 0, 1, 2, and 3, -10, -12. They can't contain something like 1.5. Another limitation, I guess you could say, of integers in C++ of the type int is that it has a maximum and a minimum. And the maximum is roughly 2.1 billion, and the minimum is roughly -2.1 billion. It's a little bigger and a little smaller than that, but that's the rough range of their abilities. So if you try to set one to 5 billion, you're going to get something wonky that isn't exactly what you're trying to do. These variables are uninitialized at this point, and what that means is that we don't know what values are inside of them, or at least the C++ spec doesn't tell us what values are inside of them. we can look at them and we can use them, but it's probably a bad idea since we're not positive exactly what values they are. And so you'll want to get into the habit of initializing all of your variables. You can do that on a separate line. Like let's say the initial velocity of our car is 0 and the initial acceleration of our car is 0. We can initialize these variables to 0 like this. This equal sign is called an assignment. And what that means is if you put a variable on the left-hand side of the equals and you put something on the right-hand side, then the right-hand side will be assigned to the left-hand side. So what I'd like to do today is calculate something called a distance. Okay, and we're going to calculate this distance based on a velocity and an acceleration. I guess we'll also need a time, but we're going to assume a time unit of 1 to make our math a little bit easier. Just so that you can see a little bit. So if you want to know how far a car that's going at 0 miles per hour and accelerating at 0 miles per hour, that'd be pretty easy. So let's go ahead and give these some numbers. We'll use meters and seconds. I think it's probably a little bit easier. So the distance starts off at 0. Let's say the car is going at 5 meters per second, and let's say it's accelerating at 1 meter per second squared. Okay, and we can compute how far this car goes given this period of time if we were to write this code correctly. There we go. So you can see I've done a couple of assignments. Now, I can use these variables in any place that I could use numbers before. I can use them in calculations, anything like that. The assignment, though, the variable has to go on the left-hand side of this equals sign. That's what we're assigning to. So in this velocity equals 5 line, the 5 is being assigned to this velocity bucket, this integer that is named velocity. So distance in this case, if we're using a time unit of 1, is 5 times 1, if you want to explicitly write it here. But we're going to use the variable velocity. And so velocity times 1, which would mean 5 meters per second times 1 second, plus a half times the acceleration times the time squared, and the 1 times 1 is just 1. Like I said, it'll make our math a little bit easier. So the distance you go, if you're accelerating at 1 meter per second and you're already moving at 5 meters per second, the distance that you will go is whatever the result of this equation is. Okay? So let's go ahead and see out this. Run this program, check this out, and see what this results in. These menus really haven't changed much. You're still going to start without debugging. It'll ask you if you want to build, say yes. A lot of times I turn that off. And you'll see that it runs and it works and it outputs 5, which might not be what you anticipated if you've looked through the math deep enough. But there was a small little thing here. Hold on a second. Let me close that window. There was a small little warning here. Now, this is not an error. This is a successful compilation. This warning basically just says, hey, there's some logic that maybe you didn't think about. Maybe you missed something. Maybe you should go back and look at this line and make sure you're doing exactly what you think you're doing. And that logic is basically, hey, the end result of this computation is actually a double, not an int, but this assignment is assigning it to an int. Okay, the reason for that is because this 1/2 is using double arithmetic, which forces this multiply to be double arithmetic, which forces this add to be double arithmetic. So the end result is something like 5.5, but then we're assigning it to an integer, right? And so we're getting a value of 5 because, as we saw before, the decimal is truncated when you assign it to an integer. One way we could fix this is by changing this int distance to a double distance and then rerunning this thing. I'm going to turn the dialog off and just automatically build when I tell it to. You can see the warning went away, and for those of you running at high enough a resolution, you can see that this says 5.5 here. That's great. So, double. A double is a type that is allowed to have decimals, and in fact, it's allowed to up to 13 digits of precision. That can be before the decimal or after the decimal. Floats are a smaller memory footprint but have less precision, something like 6 or 7 digits of precision. whereas doubles have more digits of precision, but they take twice as much memory. As far as this course and this intro video tutorial goes, float and double can really probably be used interchangeably. If you're going to have lots of calculations, it might make sense to think about this more carefully. If you're going to have some other types of issues that are going on, you'll have to think about this very, very carefully. But you can see the result of this is going to be a double, so using a double here is perfectly fine. Okay, so that's two types. We've got three. We've got int, which is just integers, doubles, which are anything with decimal places and kind of a scientific notation, number of precise digits, floats, which are just a little less precise, and they actually have bigger and smaller exponents, smaller range of exponents than the double does, meaning they can have less zeros before or after the decimal, before they're significant digits, than a double can. But that's basically the numerical types. There are other types. There's a char type in which you can hold a single variable, single character. Sorry, it is a variable. And so sometimes what I like to do is use a character to ask a user if they wish to continue or do another calculation. And characters go in single quotation marks as an apostrophe, whereas strings go in double quotations, which we saw before. You can make this output a little fancier by using the string, if you remember the string. So chars are another type which holds single characters. Sometimes people call them chars. Sometimes I'll call them chars, something like that. Bool is another type which stands for Boolean. It's kind of a wonky type in C++, but it has its place. And it can hold true or false, more or less. I don't use this very often, but it can be useful in certain situations. So, true or not. I'll call this true or not. This kind of casing where you capitalize every letter after the first word. You capitalize the first letter in every word after the first word of your variable. It's called camel case. It's used a lot. And so you can see here I can assign this to true or false. It turns out if you try to output something like a bool, then you don't get the words true or false. Mostly because C++ doesn't actually handle bools that way. But I'll go ahead and demo that real quick. You can see it says the output of true or not is 0. It turns out that anything that's non-zero is true and 0 is false. And so the output of false is 0 because 0 is false. And if we change this to true, the output should be 1 because that's kind of like the default value for true. Let's go ahead and try it. Yep, so you can see there the output was 1. Alright, so now we've handled variables. This video is getting kind of long. We're sitting at about 13 minutes, but I think I can talk about cin in just a couple more minutes and not make it another video here. So cin is console input. That is how we're going to read in information from the console. And so, for example, if I wanted to change this velocity and acceleration up here, I could ask the user to enter it for me. So I'm going to go ahead and prompt the user by saying, hey, please input an integer velocity and acceleration. And what's great about this is instead of this calculation happening the same way every time, now it can be whatever the user types in. You use cin a lot like seout, except the arrows go the other direction. They are greater thans rather than less thans. And the idea is that the string is being pushed into the console when you do a seout, so like this thing is being pushed into the seout. Whereas in a cin, you're kind of taking stuff out of the console and pushing it into the variables. So if you want, you can read in a variable or two, like so. Now you can do this to as many things as you want. There are lots of ways to break the cin thing. Like if I type in a word instead of a integer right here, this thing is going to break pretty horribly. But the cool thing is that it won't crash. It will just kind of fail. And I'll still get some output here even if I type in a string. And so I'll go ahead and show you guys that. I'm also going to comment some of these things out that we're not using so they don't show up on our output anymore. Okay, so these two cin statements, they will read in the first integers off the front of the stream that they can. The stream is what it is when you're typing into the console. And if you type something that's not an integer, it will break. So let's go ahead and run this so that you can at least see what happens here. So it says, please input an integer velocity and acceleration. Maybe my velocity is 10. Maybe my acceleration is 2. And it says the distance is 11. So if you're accelerating at 2 meters per second squared, and you're already going at 10 meters per second, then your distance is 11 meters. That's how far you'll go in 1 second. Okay? Hopefully that makes sense. It's pretty reasonable. We could try it again. If you're going at 1 mile an hour and you're accelerating at 32 miles per hour squared, then you're going to go 17 miles in the next hour. Okay? That's how this works. It's pretty straightforward. You could also view those units as whatever you want. I know I put in my file that it was meters per second, but honestly, as long as they match up, you can use whatever units you want. So that's how this works. Every time I run this program, I'll put in, the first number I put in will go into the velocity, the second will go into the acceleration. It will do this computation and output this. And this is the great thing about CN, is that you can change the behavior of your program. You can make different things happen. This is also kind of the great thing about variables, is because without variables you can't do a CN that makes much sense. They have to be pushed into variables. They have to have some place to hold the memory that you're typing these numbers into. And that place is going to be your variables. That's it for this video. Hopefully that covers everything. Goodbye!